Hello students, this is lesson U2A01. In this video I am going to go over assignment U2A01a, which is graphing parabolas by using a table, axis symmetry, vertex, and identifying roots. So we're going to follow the instructions here. It says to identify the vertex, axis symmetry, min-max value, and X-intercepts of each of the following equations, and then we have to graph out what the quadratic equation actually looks like. So let's take a look. So what I have here is this is a very odd looking quadratic equation, would you say, right? I have so right now it's written in standard form, okay? And why I say it's written in standard form, well, that's because, as you recall in the previous video, this is the standard form of a quadratic equation. So a couple things that we can do, okay, is if we're trying to graph this thing out, okay, we need to be able to identify, like, where's the axis symmetry, okay? So that's the quickest thing that you can do, the very, very first thing that you can do. So the formula for the axis symmetry, if you recall, it was negative b over 2a. So looking at this right now, seeing the standard form of the quadratic equation, written one on top of the other with the problem that we're looking at here, we can see that a is equal to 1/3 and b is equal to 1. So therefore, the axis symmetry is going to be negative 1 divided by 2 times 1/3. And this turns into negative 1 over 2/3. And if you look at this, this is actually going to be negative 3 over 2. So the axis symmetry is located at negative 3 over 2, or really it's x is equal to negative 1.5. And the trick is this, okay? So the axis symmetry is going to be located at negative 1.5, which I'm going to put a dashed line right down, okay? Right down negative 1.5. And what we're going to do with this is we're going to create a table from here. So I want to make a little chart, okay? I want to write my x, I want to write my y, and what I'm going to do is I'm just going to write out 5 rows, okay? And I want to place the axis symmetry actually in the middle here. I want to write negative 1.5 in, okay? And then what I'm going to do is I'm going to figure out other integer values, so negative 2 and then negative 3, away from the axis symmetry, and then I have negative 1 and 0. And then what I'm going to do is I am going to figure out what are the y coordinates, okay, as a result of this. So what we can do is I'm just going to pop this into my calculator. This is probably the most efficient way of doing this. So I want to go over to my calculator. And I'm going to press y equals. And I'm going to clear. And what I'm going to do is I'm going to pop in 1/3. So 1 divided by 3. Notice I'm putting in parentheses, because if I don't, your calculator will interpret, well, it will go through performing orders of operation, and what you intended, okay, may not necessarily be what the calculator is telling you, okay? So you're going to have x, whoops, I did not mean to put it in that, because my calculator setting is in a different setting right now. I need to turn this back into function. Sorry about that. So one more time. So I'm going to put in 1/3, close parentheses, x squared plus x, and I forget what the c value was, so let me go back over here. Minus 4/3. Okay, minus 4/3. Okay, and what I'm going to do, okay, I'm going to show you something here. Yes, we can certainly try and graph this if I press zoom. And I'm going to graph this on the standard zoom setting, so I'm going to go to zoom 6. We can see that the parabola should look something like this, okay? But what I'm going to do is I'm going to do something else here. I want to show you. So I want to press second mode. And there's a way for us to evaluate, okay, the parabola. We can certainly press trace and evaluate the parabola that way. Actually, I'll do this first. So let's evaluate the parabola here, okay, by pressing trace, okay, and you're going to press -2, right, because that was one of the x coordinates that we're trying to evaluate. If I hit enter, I'll end up with -2. So I'll go over here. I have -2. Oh, and then we have -3, of course. So I'm going to hit trace again, -3, and then I have -1.33. And I want -1.5. So -2.083. And then -1 and 0. And 0. Of course, it's going to be symmetrical, right? So that was to be expected. So it's -2 and then -1.33. Okay? So what we have then is, okay, at -1.5, we have -2.083, and that's really tricky to graph, right? That's okay. So I have that. And then I have -1 is -2. So it's there, and then at 0 it's -1 and 1/3, so that's like right there. And similarly on the other side, I'm going to end up with something similar, okay? So I have something like that. And if you look at this, probably this is not enough, okay? But I'm telling you now, when you're graphing, okay, you should have, at standard, okay, 5 points minimum. So right now, just by the way it looks, it doesn't look that fulfilling, does it now? Okay, maybe I'll put in 2 additional points on either side, okay? So I'll do it again for 1 and then for 2. So I'm going to do it again. For 1, press 1. So it's 0 and then 2 is at 2. Okay, so at 1 is, what was 1 again? I forget. 1 is at 0 and then 2 is at 2. Okay. So 1 is at 0, and then 2 is at 2. And without doing any work at all, because I know that the parabola is symmetrical, it should be the same on the other side. So at -4, I should have 1, and then at -5, I should have 2. And this is beginning to look a little better. Right? That's the shape of the parabola. Okay, and then, so right now, this point right here, okay, is known as the vertex. And this is going to be a, well, is it a max or is it min, guys? Right? So this being the lowest point on the graph, this is actually a min. And the min is located at -1, 1.5, comma, -2.0833. That's the minimum. And then last but not least, the question here is asking for the x-intercepts of each, right? So how do we find the x-intercepts? We actually found the x-intercept. The x-intercept is located at -4 and +1. So the x-intercepts, okay, or the roots, okay, root 1 is -4 and root 2 is at 1. Okay? Let's try another example of this. This time, where the leading coefficient is negative. Okay, so we're going to attempt this again. So I know that x is equal to -b over 2a. So it's going to be -2 over 2 times -1/2. And if you go through the process here, this actually becomes just +2. So my axis symmetry is going to be located at +2. I'm going to go through the same process again. I'm going to create a table. I have x and I have y. And again, I'm going to start off with just 5 rows. So I have x is equal to 2 right in the middle. And I'm going to go 2 below. So it's at 1 and then 0 and then 2 above. 3 and 4. And now I'm going to figure out what the y coordinates are. So I want to jump over to my calculator and I want to enter in -12 x squared. So I go over here and I enter in negative 1 over 2 x squared plus 2x minus 3. I believe that was the equation. Yes, it is. And what I'm going to do now is I'm going to evaluate these, okay, at those respective points at 0, 1, 2, 3, and 4. So let's take a look. So I'm going to hit trace. So I'm going to hit 0, and it's at negative 3. So I go over here, and then at 1, and it's at negative 1.5. And then I'm going to do it again at 2, and it's at negative 1. And it's going to be symmetrical. So at negative 2, it's at negative 1. At 1, it is at negative 1.5, so it's like right there. And then at 0, it's at negative 3, so it's like right there. And it's going to be the same on the other side. And once again, it doesn't look that promising. I'm just going to add in 2 additional points, okay? So I'm going to go over here. So I'm going to throw in negative 1. It's at negative 5.5, and at negative 2. And it's at negative 9. Okay, so at negative 1, it was at negative 5.5, which is 4 or 5. So it's right here. And then at negative 2 went all the way down to negative 9, which is like right there. Went off the graph. It's okay, though. And then on the other side, I expect it to be perfectly symmetrical. So I anticipate the graph looking like this. Okay, so this guy right here, okay, that's the shape of the graph, okay. This point right here, okay, is going to be our, well, that's the vertex, right? So is this a min or a max? This is actually a max, and the point of the max is negative 1, so it's 2, 1. That's where the max is located, okay. And what about the x-intercepts? Are there any x-intercepts? There are no x-intercepts. Okay. All right. And do I want to do another one with you guys? I think that's it. But let's say in the off chance, if you were asked to find out what the x-intercepts were, and it didn't come out to be as nice as this, okay, what you would have to do is go through the orders of operations, not orders of operations, what am I saying, the quadratic formula, and to apply that to figure out what the x-intercepts are. But you know what? I am less concerned with x-intercepts. Let's not even put that in here. So for this assignment, I'm going to modify it, okay? But you're not going to go through finding the x-intercepts. You just need to graph this out, okay? All right.